In this video, I'm going to work through the notes that I've posted for you guys on radians and degree measure. Use the timestamps to get to what you need and skip what you don't. A lot of it you can get by just reading yourself, but if you want me to talk through it, here's what I'm doing. So trigonometry is derived from the Greek language and literally means the study of triangles, which is how trigonometry was established. Since the development of calculus, the role of trig has expanded beyond the study of triangles. Trig plays an important role in establishing many functions, perspectives, and applications used in calculus and other advanced math courses. So we're going to take a deep dive into angles and radians and degrees. So let's talk about angles for a second. An angle has an initial side and a terminal side. The initial side is a ray, and then if you open it up, that gives you the terminal side, and the area in between, the distance that's covered, is the angle. In standard position, you can put an angle on a coordinate plane, and if you put the vertex, which is the little point there the two rays meet, if you put the vertex at the origin, the initial side will always be on the x-axis, on the positive side, and then the terminal side ends up wherever you want. So it could be less than 90 degrees, which means that it would open, say, to here, or you can go all the way around, or to this terminal side, or you can keep going multiple distances around the origin to get different angles. So an angle is determined by rotating a ray around its endpoint, and the starting position of the ray is the initial side, and the end of the ray is the terminal side. The end point of the ray is the vertex. And as I mentioned, when you place it on a Cartesian plane with the vertex at the origin, that's called standard position. So positive angles go counterclockwise, which is like that. And negative angles go clockwise, which is like that. So these are positive, these are negative. Angles are labeled with Greek letters like alpha, beta, and theta. Note that in this first example, we have coterminal angles because angle alpha is a positive angle of 120 degrees, but angle beta is a negative angle of negative 240 degrees. And notice that they have the same initial side and terminal side. So if they have the same initial and terminal side, they're called coterminal. Angles that are greater than 60 degrees are coterminal with smaller angles. So for example, here, this angle went all the way around back at 390 degrees, and it's coterminal with an angle of just 30 degrees. So if we want to find other angles that are coterminal, we're going to add or subtract 360 degrees. So if you think about this first example of negative 90, that means that we started with our initial side here and we went 90 degrees in the clockwise direction. So we need to name two other angles that are coterminal. Well, if we started in the positive position and went all the way around to there, that would be 270 degrees. So a 270 degree angle is coterminal. Or if we went in the negative direction, like all the way around and back, that would be 360 degrees all the way around and another 90, so we would get negative 450 degrees. If you think about 358 degrees, 358 degrees is going to be just barely shy of a whole circle, right? So we went all the way around and then just barely made the whole circle. So that's our starting one. Well, we could start and just do, well, what's the negative angle from there to there? It would be -2 degrees. Or we could go all the way around and back. So that would be 360 degrees around and 2 more. So we would have -362 degrees. All right, lastly, we have 450. This one should be somewhat similar to the first one that we did. So 450 degrees, here's our starting, our initial side. We're going to go all the way around, that's 360, and then we're going to go another 90 degrees. So this is our terminal side. So to be coterminal, well, we could just do this 90 degrees, so that's a positive 90 degrees. Or we could do just a single rotation in the negative direction to -270 degrees. So hopefully that helped you think about angles a little bit more. The measure of an angle is determined by the amount of rotation from the initial side to the terminal side. One way to measure is in degrees, which is what we just did, and this is what you've used in geometry. In trig, we typically measure angles in radians, and this type of measurement will come handy in calculus. So let's define what a radian is. A radian is the measure of a central angle theta that intercepts an arc S equal in length to the radius of the circle. So this radius here is the same length as this radius here, because all radii are the same length in one particular circle. And then we say that the arc that is made from that angle, we're going to set it so that it is also the same distance as r. So theta is measured in radians in that case. Because the circumference of a circle is 2 pi r units, it follows that a central angle of 1 full revolution, counterclockwise, corresponds to an arc length of 2 pi r. Because 2 pi r is the circumference of a circle. So if we went all the way around the circle, the circumference of the circle would be 2 pi r. So we know that 2 pi is approximately 6.28. So there's just over 6 radii lengths in a full circle, as shown in this diagram here. You can see that they went 1, 2, 3, 4, 5, 6, and then there's just like a smidgen more. Because the units of measure for S and R are the same, the ratio S over R has no units. It's just a number. It's just a real number. And because the radian measure of an angle of 1 full revolution is 2 pi, you can come up with the following. So if we went halfway around our circle to there, we know that that should be pi around the circle, the distance of pi around the circle. If we keep going, that's terrible, we go another pi around the circle. So all the way around the circle is 2 pi. So we can break up our circle into different units of pi, because that's going to be an easier way to talk about radians than to talk about 6.28 as a value. So we know that halfway is pi radians. We know that if we went a quarter of the way, like that, that would be 1/2 of a radian. If we went a 1/6 of the way around, that would be 1/3 of a radian. And radians are counted in terms of pi to correspond with revolutions of the circle. Okay, so I'm going to stop this video here just so they're not so long.